Here's the solution for the second Newton's second law problem, which is a series of 3 crates. So we have to figure out what we are going to isolate. Note we can only isolate one object at a time. So what we want to ask ourselves, do all the crates have a different acceleration, or are all the crates accelerating at the same rate? It makes sense that they must accelerate at the same rate. They are all tied together by cords. They're not springs, they're cords. In fact, if you were the 48 Newton force and you never looked behind you, you just kept on walking, you would never know that there were 3 crates. You wouldn't care. All you really would like to know is what is behind you. So these problems I call shrink and swell problems. Since the acceleration is all the same, the first thing we can do is combine all of the problems, or all of the crates, into one giant crate and figure out the force that acts on the one giant crate. Here's the ground. Here's the one giant crate, which has a mass of 12 kilograms. Notice, T1 and T2, the cords that act between the crates, have just vanished. We don't know their masses. We treat them as massless cables or massless strings. They don't exist. So we have to look at the forces that touch the outside of the crate. Let's see what we have. We have, which touches the outside. Since this touches the 5, it must touch all of them. 48 newtons at 18 degrees. We have the weight of the crate, mg, which from previous problems we may not need to use, but it would be 12 kilograms times 9.80 meters per second squared. We have the normal force, and we also have a friction force. Now we have to be very careful here. The question said a friction force of 8 newtons acts on each crate. Since we have 3 forces then, 3 8-Newton forces, they all act in the same direction, to the left. They must be added together. They are vectors. The total amount of friction on the 3 crates is 24 newtons. I need my axes again. We have an X and a Y. And this problem looks very similar to the previous one. 48 newtons cos 18, 48 newtons sine 18. And once again, these are the only 2 forces in the x direction. Sum Fx equals max. 48 newtons cos 18 minus 24 newtons equals 12 kilograms times A. A is 1.80 meters per second squared. So that is the acceleration of everything. How are we now going to get the other 2 tensions, T1 and T2? Let's call T1 the tension between the 3 and the 4 kilogram crate. Let's call T2 the tension between the 4 and the 5. Again, T1 is between the 3 and the 4. T2 is between the 4 and the 5. We need to isolate an object to get T1 or T2. Here is the easiest thing to do. Get T1 first. So we want to pick an object that has as few forces as possible but does have T1. I'm going to isolate the 3 kilogram crate. So if you isolate the 3 kilogram crate, what do we have? This is the force we called T1, N, mg, and 8 newtons of friction. Notice, T2 does not touch the 3 kilogram crate, nor does the 48 Newton force. To directly act on an object, a force must touch the object. I'm not redrawing axes since we must use the same axes for every part of the problem. But if you look at this, very similar again. Sum Fx equals max. T1 minus 8 newtons equals 3 kilograms times the acceleration we just found, 1.80 meters per second squared. This gives us T1 as 13.4 newtons. Now we need to get T2. Remember, T2 was the tension between the 4 and the 5. Once again, we do have to be careful what we isolate. There are many things you could isolate. I am going to isolate what I would consider the easiest object that has the fewest amount of forces. I'm going to combine the 3 kilogram and the 4 kilogram crate. If you do, when you combine the 3 and the 4, you now have a 7 kilogram crate. And remember, now T1 has vanished, and the 48 newtons never touches them, so what we end up with is this. T2, N, mg, and since there are 2 crates this time, 16 newtons of friction. Sum Fx equals max. T2 minus 16 newtons equals 7 kilograms times A. When you solve, since A again is 1.80 meters per second squared, you end up with T2 equals 28.6 newtons. And these are your 3 answers. You must just be careful what you isolate, or when you pick an object, to only draw the forces that directly touch the object.